Hello, thanks for joining us. I'm Katrina Schweiker, Application Specialist at Blue Marble, and I'm here with my colleague David McKittrick.
Hello everyone, and thank you for joining us today for the third in our LiDAR Processing webcast series. Today, as you can see on the screen, the theme is going to revolve around various flavors of editing and filtering LiDAR data. Last time, we talked a little bit about the LiDAR module, some of the functionality that brings to play. Prior to that, we introduced the idea of LiDAR kind of more in general. We're getting a little more into the specifics now, some of the functionality that may be relevant in your workflow. So let's take a quick look at some of the basic themes that we're going to be covering today. We're going to start by introducing the process of cropping LiDAR. This essentially allows you to address the geographic extent of your point cloud. As you can see in the little image on the left side, that's an example of a point cloud that has been cropped to the extent of, in this case, it's a property. So we'll go through that procedure. How do you crop it? You can do that in multiple ways. Kat's going to jump in and talk a little bit about the filtering process, where we actually look at some of the characteristics of your point cloud and identify points that are relevant to your workflow. We will then take a step deeper into that process and look at probably some of the functionality that's not immediately apparent within Global Mapper, some of the advanced filtering options. We will then address the idea of editing those attributes, as well as taking the existing attribute structure and removing what's not needed. We will talk through the process of modifying those, adapting them. Now, this is a manual process in the context of what we're going to be talking about today. Next time out, we're going to be introducing some of the automatic editing tools, or the automatic update of classification tools. So this is just a preliminary introduction to this functionality. We will then talk about modifying your point cloud in terms of its geometric structure. A couple of different workflows we'll just introduce very briefly for moving the point cloud in a horizontal context, essentially shifting it if it's offset by a known amount, or indeed geo-rectifying it. If you have erroneous or non-existent ground control, you can actually define where that point cloud should exist on the surface of the Earth using our rectification tool in Global Mapper. And we will wrap up by adjusting the vertical characteristics as well. A couple of different scenarios to offset the existing Z values, either universally or based on a new tool that we introduced in one of our last live presentations, our LiDAR QC tool.
So before we introduce some of the other cropping options, I'm just going to show you a quick option here to crop when importing data. So we already have some data loaded here. I'm just going to drag in another LiDAR file so we can look at this import dialog. And you'll see under limiting what points are loaded, one of the options is loading points within a specified bounds. So I would want to check that, and then here's our familiar bounds dialog box. So that could be cropping to a selected area feature if I already had an area feature selected, specifying some exact geometry, or also our draw box option. So this will let you, using whatever reference data is already loaded, I could specify a certain extent here and only load the LiDAR data within that extent.
Okay, and that's obviously something that you would enact if you knew the extent of the point cloud that you're working with was beyond the bounds of the project you're working on, for instance. So more often than not, I would encourage folks to bypass not only this option, but any of the filtering options during import. I brought this up when we introduced the LiDAR in our first session. It's a good idea to take a look at the characteristics of the point cloud before you actually embark on any editing. So with apologies to Katrina, I'm going to cancel this, and we have a point cloud loaded already. And again, the objective in this introductory section is to filter, basically remove points that are not required. Now, as you saw in that preliminary PowerPoint slide, I had limited the point cloud to the extent of one of these property boundaries here. This is a point cloud in the little town of Castine, which is probably about, I'm going to guess, maybe 50 miles east of where we're sitting right now, right here on the coast of Maine. Let's assume that I want the LiDAR data for just this polygon. First thing I'm going to do for simplicity is turn off the point cloud itself and to isolate the property boundaries here. I'm simply going to use my digitizer then to highlight a specific area. Now, this is obviously a property boundary, but this could also be some sort of jurisdictional boundary, maybe a county or a town. So if your LiDAR data extends beyond the extent of your government area, this is another method you could use then to limit it to those boundaries. I'll turn on the point cloud once again. And the process of cropping is very simple. It is a right-click option, and those of you who have been using Global Mapper for a while will be well familiar with our digitizer right-click menu. Where we're going specifically here is to the crop, combine, split functions submenu. And you'll see some of the tools we have here. The important one for us is this second option, to crop my loaded features to a selected area. And there's really not much we need to do beyond this. We can confirm all the settings here, basically where the cropped data is going to be placed. If we want to mark the cropped features as being deleted, in other words, if we want them to be removed from view, and assuming that this is intended to be a more permanent process, we'll go ahead and check that box in this case. You will notice this is a fairly recent addition to this dialog box where you can essentially invert the cropping. So rather than retaining what's inside the polygon, we could retain what's outside if that's relevant. If you want to essentially cut a hole in your point cloud, maybe you've got some higher resolution data, you want to eliminate the lower resolution point cloud from that area, certainly by all means you can invert it. So this is really all we need to do. The drop down, by the way, allows me to specify into which layer my cropped points will be placed. Now, because I'm removing the necessary points, I'm just going to keep them in the same layer. But you can also use this tool to create a new layer, which is a very useful function as well. So it may be a more common workflow. I've got my master point cloud, but I want to create a permanent subset based on these geographic extents. So very quickly, simply click OK, and it's going to go through, analyze the point cloud, and eventually, as you see, give me a subset of that data, limited to the extent. Now you will notice a checkbox I inadvertently forgot to note. It also removed my parcels. The parcels or the property boundaries were there simply to give me that outline, but they were also cropped based on that process because the checkbox included points, lines, and areas. So we talked about cropping during import. We've talked about cropping after the data has been loaded. The other thing to note here, and I'm not actually going to show this, but you can also crop LiDAR data during the export process. So if your workflow requires you to import maybe multiple tiles of LiDAR data and export a single file, again constrained to a certain area, as you will see when we get into, I think it's the final LiDAR processing webcast, we'll talk about exporting LiDAR. You can crop the data at that stage as well. So multiple options for you to geographically limit the extent of your point cloud.
And that would be that bounds tab that we just saw with import too.
You will see that again and again.
Yep.
Exactly right, Katrina. Again and again in the application, you'll find that multiple options in that dialog box for limiting the extent not only of the in terms of cropping, but also some of the analysis tools you perform as well. One other thing I want to show you, kind of mirroring one of the functions I referenced when I brought up that dialog box, the idea of taking a select group of LiDAR points and migrating them to another layer. I'm going to do this manually, just based on this subset of data that I have left here. This is based on a selection. Now, I can select LiDAR points simply by dragging my digitizer. You will see it appears like a solid red box, but actually it's multiple small red boxes outlining each of my points. Those are the selected points. There's multiple things I can do with those points, and you'll see in some of our workflows to come, the selection process is key to some of these procedures. We can also select, by the way, or change that process of selection by going to our advanced selection options and choosing poly select. Now here's a clue here. Katrina's actually pointing to my monitor here. The clue here, there's a little icon. This indicates that it's actually a button in the toolbar as well. Right up here in my toolbar, we can perform the same selection process. Basically what this allows me to do now is to draw a polygon. I'm not actually drawing anything permanent, but rather selecting based on a polygon rather than a uniform rectangular feature. Again, ultimate result is a series of selected points. Now, what I intend to do now, it's a variation on the idea of cropping, is simply copy and paste. Now, this part you'll not see on my keyboard. I'm going to hold down the control button, hit my C button. My points are now copied. They're in my clipboard. You will see something when I try to paste them, Control V. Gives me the option of determining where these are going to be pasted into. Once again, I can paste them into the same layer. I'm not sure when you would ever do that in this case. You would have duplicate points at exactly the same location in the same layer. Not that useful. What I find most useful here is to create a new layer. So we can create a layer to paste these into, or we could add them to a previously existing layer as well, if that's relevant to our workflow. Once we've selected this and clicked OK, it's going to give me the option of naming it. I'll call this new layer and we'll click OK. And in my overlay control center, you'll now see a new layer. Actually, you're seeing a couple here. Turn off everything else.
And then either the escape key or there's a button to clear the selection as well.
And you can see now we have the point clouds limited to that area. So again, variation on the theme of cropping.
And I'll just mention, if you're not super comfortable with keyboard shortcuts, the edit menu also has those copy and paste options.
So moving on from the idea of cropping geographically, we're going to take a look at removing points that are not relevant to your workflow based on the actual characteristics of each point. As I mentioned, and I've mentioned a few times during the course of these presentations, before you embark on any procedure where you're using point cloud data, it's a good idea to take a look at the inherent characteristics of that point cloud. Specifically, what we're going to do before I hand over to Kat here in a couple of minutes to actually look at some of those filtering tools, we're going to take a look at the metadata. Now, the metadata for any given layer can be accessed from the Overlay Control Center, either as a right-click option, or as you'll see, the keyboard shortcut is a double-click with the letter M held down on your keyboard. The metadata dialog box gives you summary information about the point cloud in general, including the number of points. If I scroll down, you'll see coverage area, things like that. But what we're most concerned about now is the statistics. And this is unique to LiDAR. You'll not see the statistic tab in the metadata dialog box for any other type of data. Statistics includes a breakdown of the classifications that are currently identified within this point cloud, including the number and percentage distribution of those classes. Now, armed with this information, you can then perform filters. You can remove the points that are not required with a higher level of information than if you'd just done this during the import process. So I'm going to hand over to Kat now, and she can take a look at some of the options for filtering the data based on this information.
So just as we saw when we were cropping our LiDAR data, we could also apply filtering during the import process. We'll skip over that option here, but you'll see similar to what we're about to do with filtering, it could be applied during import. So for example, if you wanted to load only the ground data. But what we're going to take a look at here is the filter button that will let us quickly show or hide certain classes. And before I do that, so right now we're coloring our LiDAR data by elevation. I'm going to go ahead and switch that to classification so we can sort of see exactly what's happening here. So in the previous video, you saw how to color the point cloud by different categories here. This one, we have gone ahead and classified our data. So we've got some buildings in orange and some vegetation in green. So if I take a look at the filter LiDAR data, this is going to let me quickly toggle on and off certain classes. So for example, I could turn off the building points. Another option that I'll mention that's sort of hidden here is also the color of our points, so the default color applied to our LiDAR classes. And a couple of other options. If you right-click on this filter menu, either here or in configuration, you'll get these class name, class color. So if you had custom classes, or if you wanted to change the default colors for these classes, that is how you would get to that. Class groups we may come back to in the extraction data, but that relates to which classes are considered vegetation or buildings if you do have any customized classes that are not the ASPRS standard.
So the other thing to note, while the button that Katrina accessed to get to this filtering dialog box, and this is something you're going to use a lot. There's very few workflows in Global Mapper that will not require you, when working with LiDAR data, to remove some points that you don't need. The unclassified points are not really useful in many situations, so you'll be using this a lot. And we've put a convenient button, as we pointed out, in the LiDAR module toolbar for that purpose. If you're not a user of the LiDAR module, it is important to note that this dialog box, or this function, can also be accessed from the configuration dialog box. There is a LiDAR section in here that has exactly the same options as you saw in the dialog box. So if you're not using the LiDAR module and you want to import a point cloud and simply remove the points that are not required, you can still do that. Convenience of the module, obviously, we've elevated that to be a button right here in the toolbar.
And those filters are going to kind of preserve as you continue using the application, but you will get a warning dialog if you load new data and you happen to have a certain class turned off. There is a pop-up that will come up that says, you've got filtered view. So that would be where to go to turn back on all your different classification types.
It is one of the global settings that you set it and forget it, it will be retained, which may be useful in certain situations. If every point cloud that you load is automatically filtered to remove the points you don't need or add or include the points you do, that will be retained, as Kat said.
So another option for filtering LiDAR data is accessing some of those additional LiDAR attributes. And this is our advanced filtering dialog. One way to get to this is by first having selected some LiDAR points. So just with what we saw before, I'm going to go ahead and draw a polygon, select a subset of data here. So this might be a certain area that I'm looking at, or it might match some query that I've run. And then with the digitizer tool active, so again, here's my digitizer tool, I'm going to right click and go to advanced selection. We want this advanced filtering option. So filter selected LiDAR points by all of the other attributes. So let's bring up that dialog. So you'll see a whole bunch of additional options here. We've got all of the classes that are currently in our point cloud are there, as well as all the return types, so we could do some filtering in that way. You'll also see access to things like the explicit elevation or the height above ground. So this would be, height above ground would be generated when you do that visualization. That is a kind of a model of a basic height above ground. We can also filter by color. So if we had RGB values associated with our points, we would be able to filter to match a certain color value. Same with intensity. So that would be similar, maybe to pick up on certain features in our data, either the RGB or the intensity might help identify certain features. Some of the additional attributes, things like the scan angle, the overlap values, those are all accessible here. So we could take our current selection and restrict it down to a smaller filtered subset.
Yeah, and it is worth noting that this workflow, as noted at the start, is based on a selection. If your intent is to perform this level of filtering over the entire extent of the points within a layer, it's just simply a case of making sure they're all selected first. You can do that based on what Kat had done, which is basically manual selection, or there is an option, oops, I have to close the dialog box here first, but you have the option to right click and select all. This is probably the easiest way to achieve that selection. Then the filters that you apply would be applied universally. The ultimate result then is a subset of selected features. So again, the filtering is a second step in that process where you take those selected points and either copy them to a new layer or you crop them out if that's necessary. So it is, in a sense, it's a two-step process. This is just a filtering of the selection. Kat, I'm just actually going to jump in here, sorry, and remove the ground points just as an example. Maybe do a height above ground filter as well. So we want to limit it to those that are below maybe 30 meters, and that's above ground. So these are just off the top of my head examples. We'll click OK, and again, the result of that is the point cloud itself has not changed, but what has been selected, as you can see, is what has changed. So I can take those selected points, as we mentioned before, Control C, Control V, and move them, migrate them into another layer if necessary.
So I think you actually did above 30 meters.
I
That
did.
was
I
like the tallest
I
trees
got
there.
the tallest trees there, but you get the idea. That filtering dialog box is very, very powerful, and obviously multiple filters can be applied concurrently, height, intensity, etc., etc. So another way of filtering data is using a tool that's, again, not uniquely positioned for LiDAR, but it's been something we've featured in other presentations, and that's our query function. This is a tool that allows you, as it says, to search your vector data. Well, LiDAR point cloud data, as you know, is vector. So using this tool, first thing to note here, by the way, once we activate the search vector data function, is we get a tabular view of our point cloud. And this in and of itself is a useful function. These are sortable columns. I'm not going to actually do the sorting right now because we're dealing with several million points. It does take a little bit of time to refresh the view, but it is certainly something you can do if you want to quickly look at points, for instance, based on intensity that are outside of what you would expect. You can sort by this column and note those at the extremities, and if necessary, you can delete them here as well. So as a viewer of the attribute structure of your point cloud, this is a very useful tool. You can also build a query. Now, what I'm going to do in this case is identify points within this point cloud that are within a certain range as far as the scan angle is concerned. Now, scan angle, those of you familiar with how LiDAR is collected, is based on the angle from the aircraft, in this case, to the point of contact on the ground. Obviously, those points that are directly overhead, or directly underneath, I should say, the scan angle being lower, are going to be points that you're going to have a higher level of confidence. The further you get from the aircraft in terms of that angle, there's more likelihood of erroneous points. So just for an illustration, I'm going to conduct a query to limit my scan angle to 5 degrees from overhead. So I'm going to build a query right here by first of all selecting that attribute, my scan angle. I'm going to choose first of all, I'm going to choose greater than. Now, my greater than is going to be -5. Now, in other words, I'm going to first filter these scan angle values that are above, only those that are above -5. In other words, I'm going to eliminate those that are below or lower than a -5 angle. In this case, we're going to conduct a new search, and you'll see the results are going to be displayed. That list now is filtered based on that value. I'm going to conduct a second level because I also want to identify those that are less than +5. So we're doing a 2-level query. The results of this we will have an accumulated collection of points that are within that -5 to +5 range. In this case, having changed the query, I don't want to do a new search, but rather search in the existing results. And again, we'll wait for those results to refresh, and we will see those results. I'm going to hit the Select All button, and we will eventually see if I quickly drag my search dialog box a little bit lower. You can see those results now displayed on my screen very clearly, following, we would assume, the flight path of the aircraft. The points that are highlighted are those in which the scan angle is within a 5-degree extent of overhead.
So we've taken a look at filtering and cropping of LiDAR data. Now we're going to move on to editing of LiDAR data. And we're going to start with just the basic example of editing individual points. So with my digitizer tool here, I'm just going to select one of these points in this point cloud. And I'm going to right click and go to edit the point feature. I could also get to this with multiple points selected. This is a different dialog than the normal modify feature info tool. You'll see that this has the classification of that individual point. Also things like elevation and intensity. You would pretty rarely edit those things on an individual basis, but they are here if you needed to. Also point flags, so things like model key points and overlap would be accessible here in this edit LiDAR point dialog. And for this example here, I'll just change my classification here. Say I wanted to make this point maybe low vegetation. If you wanted to manually modify the classes, specifically, we also have quick buttons for doing that. So this classify toolbar here, all these buttons are for manually assigning the classes. So we have for ground points, the different vegetation types, buildings, power lines, water, etc. You could also get to that with those buttons, so your selection would get that classification. So that's a manual reclassify. Yeah,
and that toolbar array is, again, unique to the LiDAR module. We introduced that one in our last session when we introduced the module. Shortcut buttons, basically, as Kat mentioned, to assign a new classification for a point or multiple points. And I guess I'm going to jump in here because while Kat showed you that dialog box, the actual use of an individual point editor is fairly limited. You're not going to do that much. What's probably going to be a more useful variation on that theme is the process of selecting and editing multiple points. Now, in this example, what we're going to do first of all, I'm going to turn on an underlying layer. This is a layer of building footprints. This happens to be the city of Portland, a little south from where we're sitting right now. But I'm not going to select all the buildings. I'm just going to select a few here. They're highlighted now with my digitizer. I'm going to turn on the point cloud once again, and you can still see the kind of the outline of what's highlighted. I'm now going to select just the points that fall within the bounds of the buildings. And this is again, it's a commonly used digitizer function. Right click again. We're going to our advanced selection options submenu, and you'll see now that we have something selected. There are way more options in this dialog box. This submenu, I should say. Specifically, what we're going to look at here is selecting all the points that fall within the selected areas. And if I choose that option, as you would expect now, all of those points that will have been selected have been highlighted and are ready to be edited. So I could, if necessary, if I wanted to make all of those building points, I could simply choose the Classify Building button, and it would assign those to that classification. Now, Katrina introduced a function in our last section where we have advanced filtering options. And it's worth noting in this context that this might be a useful tool to apply in this type of workflow, because one of the options is to limit what's selected by height above ground. Now, I'm not sure what the values are in this case, but if we needed to not only select the points that are within the bounds of the building, but also those that are above a known height above ground.
Yeah, so that would get rid of those low, maybe there's vegetation right next to the building, or...
And we'll click OK. And it has eliminated the non-building points from within those building footprints, those points that are below that threshold, that 2-meter threshold that we assigned. Now, the final thing that we need to do in this workflow is to essentially reassign the classifications for those selected points. Currently, they're still in that unclassified area. We're going to use the toolbar button for this purpose. We simply classify them as building. Confirmation that 10,581 points are being reclassified. We'll confirm, and we will use the escape button to deselect. Best way to see this obviously is to change our visualization, and as you can see, we now have reclassified the points that fall within the bounds of each of these buildings to be building points, which is a good first step if you're performing the building extraction process, which is one of the workflows that we will show in one of our later presentations. So one of the other edits you can perform against not only point cloud data, but any layer, is adjusting the horizontal positioning, if you like. And there's two different ways of doing that. I'm going to go through this quite quickly. I'm actually going to go through a specific workflow, but I just want to make sure you're aware that this is an option. We'll assume in this case that the point cloud I'm working with is offset for some reason. Maybe it was just incorrectly referenced when it was created. Maybe you want to fine tune that just a little bit. And if that's the case, with any layer, including our point cloud layer, we can right click, and you'll see here an option to shift this selected layer. This is based on a known distance, a known fixed distance, or you could perform a more advanced transformation of the coordinates. I'm not going to do that right now, but let's quickly take a look at the shift layers a fixed distance option, and we'll click OK. And you'll see a couple of variations. One is to specify an X and Y offset. If you know it's off by a certain distance along the X-axis and another distance along the Y-axis, just enter those values and the entire point cloud will move collectively, universally. You can also specify an offset based on a specific distance and bearing. If you're looking at maybe some underlying imagery and you'll see the corner of a building is off by about a meter on a bearing of maybe 45 degrees, again, entering those values in here will universally shift that point cloud. Make sure that if you're performing that type of edit, indeed, any of these edits that we're demonstrating, that when you're finished with that session, you either save the workspace to retain any of those updated values and parameters, or indeed simply export your file once again out to LAS or LAS, and the updated settings will be preserved in that external file. So again, I'm not going to do that right now, but I'm going to show you another method for adjusting the horizontal positioning of your data. And this is a little bit more of an involved process, which we've demonstrated many times. This is our rectification process. Rectification is a procedure that we would typically demonstrate in the context of bringing in some raster data that is non-geographically referenced, and you can manually position it. Here we're using an existing layer, which may or may not be precise, and we can identify within that layer control points. Maybe the corner of a building would be a good option. And if we had some existing imagery once again, or indeed if we had surveyed ground control points, we could identify ground control within our point cloud, and it would interpolate the positioning of every point based on the assignment of those two ground control points. So we have demonstrated this function in our raster processing webcast. So if you want to see more details on this procedure, we don't have time today, unfortunately, by all means go back and take a look at how we actually perform that process. So again, just a couple of different examples of tools you can employ to adjust the horizontal accuracy of a point cloud.
So related to adjusting the horizontal position of our LiDAR data, there also might be cases where you want to modify the vertical height of the data. And in this particular example, we're going to look at shifting the entire point cloud by a certain height. This is some terrestrial LiDAR data that we have. You can sort of see the different scan angles here, and if I turn off some of these point clouds, you'll see kind of where there's overlap and where there's different coverage here. So we've got the left side of the road in this bottom point cloud, and then a couple of point clouds that are more on the right side here. That one's kind of in the middle, a little bit harder to see there. And our left side of the road in this particular example, as you'll see, is slightly offset from the other two point clouds. So that might have just been the control points that were collected from those tripod collection units. But we've got a little bit of a disagreement there, and we want to just make those match. In order to take a look at that first, we're going to use the profile tool here. So I've already actually got this selected. I'm just going to look at a cross-section of the road here in order to visualize that. So we can see a little bit of difference here between the left side and the right side. If I actually change my vertical scale here, we'll see that a little bit more exaggerated. So if I go into my settings, I'm actually going to go ahead and clamp my, my y-axis of my profile here. So if I go from about 132 to about 135 here. I'm just using my numbers on the left side here to get a closer to the ground range. We can better see that slight offset between that point cloud on the left side there and the other two on the right side. And we could also go ahead and measure that distance if we wanted to. So as we saw before, a few tools that we can use inside of the profile window. One of them is measuring a subpath. And that will let me measure the actual height distance between these two point clouds.
So I think that the important measurement there is not obviously, we're not obviously measuring anything horizontal, but right at the bottom of the screen you'll see the 3D distance. Kat has just drawn what's, for all intents and purposes, a vertical line. And if I move my cursor, the value is going to change. But right in the middle of the screen at the bottom, you'll see it says 3D distance 0.1179. So I think we can round it to probably 0.1, Kat, for this example.
Yeah, so my left point cloud is about 0.1 meters, disagreeing with the other two point clouds. So we can go ahead and shift that entire point cloud up to match. And I'll actually leave this profile window open so we can see that adjustment happen. But in order to do that, I'm going to go to the options for that point cloud layer. So that was the bottom of my list here, is that left side point cloud. So to go to the layer options, either right click or double click on the layer name. And we're going to take a look at this alter elevation values tab. So this is going to shift the entire point cloud. Some other things that you could apply here, something like a scale factor. You know, if you wanted to change the units, that would be kind of a manual way to do that, or there might be other cases for that.
The one that we've used quite a lot is actually the applying a scale factor of -1 multiplies all your LiDAR points by, essentially makes them negative numbers. And we've seen that used on occasion when you have LiDAR data which is representing ocean floor. I know it's becoming increasingly common to have submarine LiDAR, and that would be one way where that Z value is actually represented as a depth rather than a height.
In this case, what we're going to do is add 0.1 meters to the entire point cloud on the left side. So that will shift everything up 0.1. And I'll go ahead and apply that. And we can see now that that left point cloud in our particular cross-section here has snapped up to match the other data.
So in our final workflow, we're going to take a look at a variation on what Kat just showed us. Now, in her workflow, she offset the elevation values or the Z values in the point cloud by a consistent amount. Every point in that left-hand side of the road was elevated by 0.1 meters or 10 centimeters in that case. In this example, we're going to use a more interpolated process because what we have on the screen here are a series of simulated ground control points. These are surveyed points representing precise elevations, ground elevations at these locations. I also have some point cloud data. It's difficult to see right now. I probably should turn off some underlying imagery here, but what we have is a swath of point cloud data following a power line. Now, we've used this data in the past. We've used this example for one of our extraction exercises. In fact, we also used this in our most recent live webinar where we introduced some of the new tools in Global Mapper 18.1. So you may have seen this before. Those of you who haven't, a quick recap. If I draw a profile along the middle of this point cloud, hopefully we'll intercept some of our power lines here. As you will see, this has some ground, it has some power lines, but we know that the elevations themselves are incorrect, and that's based on these survey ground control points that we have added to the workspace. These were derived from a shapefile, and you'll see this in my overlay control center right here. So we have 6 ground control points. The process of interpolating the ground control points is basically initiated by a new button in our LiDAR module toolbar, our LiDAR QC button. And the procedure is very straightforward. We decide or select which of the layers contains our control points, which in my case is my shapefile. We decide which of the last files that we want to apply this to. And you'll see I've got 2. One is turned off right now. Everything else should be fine. We click OK. And the first thing that we're going to see is a report of the results of the analysis of the points around each of the ground control points. The root mean square error value is noted here. The elevation of the LiDAR points, and this is an averaged value. The elevation in my surveyed points. So you'll see there's a significant offset here between what the Global Mapper sees within the proximity of each control point and what's actually surveyed. And you'll notice the difference as well noted here. So obviously there are problems with this point cloud, and the other thing to note is the offset is not consistent. You'll see variations from about 2.5, just over 2.5, to about 4.5. So Kat's procedure to apply a universal offset would not work in this situation. Rather, what we can do now is simply fit our LiDAR to these surveyed points, and what will happen is the points in between will be interpolated. We'll click OK, or click our Fit LiDAR to Control Points. Confirmation that we want to do that, we'll say yes. It's going to go through and adjust those Z values, and as you will see, the easiest way to visualize the result is once again using our profile tool.
So this is looking at the points that are close to each of those control points. So all the LiDAR data that is right near that control point.
Exactly. And you can see confirmation again. Now, this point cloud is 20 million points. Each of the elevation values in all 20 million points has been modified based on those control points.
And we are assuming that the points nearby are ground points. There might be cases where you would want to filter to just the ground. If we knew some of these control points were, for example, right next to a power pole, you'd probably want to show just the ground points.
Absolutely. And we know the tools we've seen. We saw the tools earlier in the session for applying those filters. So you may have noted I've actually got another point cloud. This is an identical point cloud to the one that we started with. I'm going to activate that right now, and we're just simply going to use this as a visual comparison. I'll turn off the control points as well, so we don't have those on my screen. So from the top down, nothing has changed visually. Using my profile tool once again, if I draw an arbitrary line right along the section that we applied those survey control point elevations to, you will see quite clearly when my screen refreshes a little bit longer here because it's profiling 2 layers, there's a distinct offset. And it is also noteworthy that while the original is a fairly consistent horizontal line, what we've applied based on the survey is actually offset just a little bit within the context of this area, but you'll see it's not a consistent offset, but it's an interpolated offset. So this method allows you to based on survey points, based on maybe points you manually survey, or even based on points that you place on top of an existing elevation model. In truth, the points I assigned in this case were actually derived from an underlying elevation data set. But you can see what we've done to the point cloud is apply the elevations from that data set to the actual points in this point cloud, giving them a more precise elevation value. So, basic objective of today's presentation was to introduce variations on the theme of modifying your point cloud, basically. The idea of geographically limiting the extent, which is what we started with, filtering based on some of the inherent attribution, and also applying certain edits. It should be noted that when we delve deeper into some of the functionality in the LiDAR module, you'll find that there are automated tools for applying a lot of those edits. So what we did today was manual. The more automated reclassification tools are to come in a future session. So if you have any questions about any of the workflows that we covered today, the folks in our tech support team will be more than happy to help you, or questions about Global Mapper or the LiDAR module in general. If you're interested in maybe talking about licensing options, maybe getting a quote, the folks down at the in the sales department, orders@bluemarblegeo.com, would be there to help as well. And if you're looking at this presentation but are not currently using Global Mapper, you can download a trial on our website, bluemarblegeo.com. You'll see the links in there to download Global Mapper. If you're not using the LiDAR module, that's also something that you can try out. One of my earlier presentations, I did talk about how you can activate that module. So, well, thank you for joining us today. Next time out, probably sometime next week, we'll publish the next in the series, which will cover some of the automatic reclassification tools. But for today, thank you very much for your help today, Katrina.
Thanks, David.
And we'll look forward to speaking to you next time.